Hey guys, so today we're going to be working on chapter 3, section 3.1. So this is actually a continuation somewhat of what we were doing in chapter 2, where we were talking about quadratic equations and parabolas. So let's go ahead and take a look at this one here. So again, just to refresh your memory, when we're talking about a quadratic function, we're basically saying it's a second degree polynomial or a quadratic equation. So a quadratic function will actually have the form of f of x equals ax squared plus bx plus c. So again, remember, this means that your highest degree on your variable x has to be the second degree, degree 2. And of course, we don't want our a value to be 0, because if a is 0, a times x squared will become 0, which means your second degree term will disappear and you won't have a quadratic equation anymore. So that's why we don't want our a value to equal 0. Okay. So in the previous chapter, as you can see in section 2.3, we actually talked about the transformation equation or the transformation form of our quadratic equation, which is f of x equals a times parentheses x minus h quantity squared plus k, right? So the first thing we actually are interested in talking about is how can we go back and forth between the two forms. So if the equation is given to you in the standard form, which is this one here, and you want to convert it from the standard form to the transformation form, which is the second one, how would you do that? And of course, if the equation was given to you in the transformation form, how would you go back and put it into the standard form? So that's the first thing we're going to be talking about here. So just looking at our second paragraph, they are saying it's easy to convert from the transformation to the standard form, where you basically start by taking the square of your binomial term. So this is where you would go ahead and FOIL the x minus h to the second power. Then you would multiply by a and then add the k at the very end. However, if you are going from the standard form back to the transformation form, then this is where we will actually need to use completing the square. Okay, so remember, we had talked about completing the square in chapter 1 when we were looking at circles. We talked about completing the square in chapter 2 when we were talking about how to solve a quadratic equation. So we're basically bringing back that same idea of completing the square. The only difference in this chapter, in this method, is going to be that on the left-hand side, we will need to keep the f of x. So we will not be able to use both sides when we are doing completing the square. So we are actually going to do all of our calculations, the adding and subtracting, multiplying, dividing, whatever we are doing, all of it is going to happen on the right side of our equation. Okay. So let's go ahead and take a look at how we would go about doing this. Now you can read this paragraph a little bit more. I didn't go through all of it, but basically what we're going to need to do is make sure that the coefficient of your x squared term is 1. If it's not 1, then we will need to make sure we are going to make our coefficient for the x squared term 1 before we actually start looking at completing the square. So let's take a look at our first example here. This is given to us in the standard form, y equals 2x squared minus 2x plus 22. They're asking us to convert it into the transformation form here. And then of course, they're asking us to sketch the graph. So let's take a look at how we can write this in the transformation form. All right, so here's our example. Y equals 2x squared minus 12x plus 22. So the first thing you have to keep in mind that I cannot do anything on the left-hand side. On the left-hand side, my y term will stay as it is, okay? So the first thing that we're going to need to do is basically make the coefficient of our x squared term 1. And right now our coefficient is 2. So normally in completing the square, we could have divided our entire equation by 2 and we would have gotten rid of that. But since there's nothing that I can do on the left-hand side, so I cannot really do y divided by 2 on the left-hand side, what I'm actually going to do is I'm going to take just the first two terms. We're not going to do this with the last term, you're just going to take the first two terms and you're going to factor out this 2 that's in the front. So we're going to actually take that 2 outside, which means if I'm taking the 2 outside, your x squared is left behind, minus keeping that same sign. Now 2 goes into 12 how many times? So of course, that's going to be 6, and then you're still keeping the x in there. So the one thing you should note is that even though we are factoring, we're only factoring by taking the number 2 outside. Well, sorry about that. We're only factoring by taking the number 2 outside. We're not factoring our x variable. The x variable does not get factored out. So only the number 2. And remember, the reason for that is I want my x squared term to have a coefficient of 1, okay? So we took our first two terms, factored out the 2, which left us behind with x squared from the first term minus 2 goes into 12 6 times, so then we were left with 6x from the middle term, and that plus 22, we're just going to bring it down at the end, okay? So now looking inside the parentheses, you can see I have x squared minus 6x, okay? So this is where I need to complete the square. I need to complete the square just inside the parentheses part. So you're going to take that x squared minus 6x, and you have to figure out what that third term should be where I'm completing the square. So remember, your process is you take the middle term, which is 6 in this case, the coefficient of the middle term, divide that by 2, and then we square that whole thing. Whoa. So 6 divided by 2 is going to be 3. And then you are doing 3 squared, which would, of course, be 9, right? So we are doing 6 divided by 2, whole thing to the second power. 6 divided by 2 is 3. 3 to the second power is 9, which means our missing term here is going to be 9. And 9 is what we need to complete our square. So coming back to our original problem here, inside the parentheses, I will now have x squared minus 6x, and then I'm going to take this 9 and add it here. Now here's the thing. Again, back in chapter 2 or chapter 1, when we were completing the square, this number 9 that we added, we would have added it to both sides of our equation so that we could maintain the balance of our equation. But I cannot do that because, again, remember, on the left-hand side, I'm not adding, subtracting anything. So since I am adding a 9 here, to keep the balance of my equation, I'm also going to subtract that 9 from right here. So by adding 9 and subtracting 9, I am not changing the value of my equation. And then at the end, we'll bring that plus 22 down again. Okay. So as far as completing the square goes, we've taken care of that. That is what we did here on the side. But now, how do we clean up this equation? Now, for completing the square, and to get a perfect square trinomial, I only need these 3 terms, which means I don't need that minus 9. I need to get it out of my parentheses. So to get it out of our parentheses, you're actually going to take this number in the front, the 2, and multiply it with this negative 9 in here. And that's how you actually bring it outside of the parentheses. So you've got your 2 in the front, x squared minus 6x plus 9, and this is all I need in my parentheses, right? I don't need that minus 9, but remember, to bring that minus 9 outside of the parentheses, we are multiplying it with this 2 in the front. So when I multiply 2 with negative 9, I get negative 18, and then you still have that plus 22 at the end. So take a minute and just kind of think about what we just did, okay? So before I clean this up, let me go back and kind of recap what we've done so far. So the first thing we did was get rid of this 2 right here in the front on my x squared term, and we did that by factoring. So we got this 2 outside. That left us inside parentheses with x squared minus 6x, and that last 22, we just bring it down as it is. Now just the inside of the parentheses, the x squared minus 6x, that's the term that I want to complete the square for. So we take our middle term, which is 6. 6 divided by 2 is 3. 3 squared is 9. Remember, for completing the square, you're always taking the middle term b, dividing it by 2, and taking a square, which is what gave us the 9. Okay, so now once you get that number 9, you need to add and subtract the 9 from your expression here inside the parentheses. So you've got your x squared minus 6x plus 9, which forms the perfect square trinomial. And then we need this minus 9, so we're making sure we're balancing our equation. But I don't need that minus 9 inside of my parentheses. So you take the minus 9, multiply it with the 2 in the front, and it will come outside as negative 18. And then you have x squared minus 6x plus 9 left inside of your parentheses. We still have that 2 in the front. And now I can combine these two terms here. And let's clean that up. So you get 2x squared minus 6x plus 9. And then when you add negative 18 and plus 22, you should of course get a plus 4, right? Okay, the one last thing we have to do is factor our parentheses part. So now we have x squared minus 6x plus 9 that we need to factor. Okay, so you can obviously use the little X method here. So you're looking for two numbers that multiply to give you 9 and add up to give you negative 6. And that will actually be negative 3 and negative 3. So negative 3 times negative 3 gives you positive 9. Negative 3 plus negative 3 gives you negative 6. So this guy factors into x minus 3, which is the same thing as x minus 3 to the second power. Remember, this is a perfect square trinomial. So it factors into the same expression. So x minus 3 to the second power plus 4. And this is how you convert it from the standard form to the transformation form. So both of these equations are actually going to be the same. Your 2x squared minus 12x plus 22 and 2 multiplied with the quantity x minus 3 squared plus 4 are the exact same expression. There's one more thing I want to actually talk about before we look at the graph for this. So you know how we were trying to factor this here with your x squared minus 6x plus 9? One little tip. So right here where we were completing the square, this number 3 is actually going to be the same number 3 that your factors will have. So right before you did the square to get the 9, this number 3 here is the same number 3 you would use when you're factoring this expression. So that would actually help you if you were looking at numbers which were, you know, difficult to factor or something like that. This might come in handy. All right, so let's take a look at how we can go about graphing this expression. Now you can use the transformation form that we came up with, or you can use the original equation to graph it. So whichever one you are more comfortable with, doesn't matter. So let's go ahead and get our grid here. Okay. Okay, there we go. Hopefully that should do it. This will be our X, Y, and then let's see. Oops. Okay. All right, so remember, you can always do a table for X and Y values. So we can do 0, 1, 2, 3, 4. Maybe -1, -2, -3, and let's see what kind of Y values we can come up with. So I'm actually just going to use the original equation, 2x squared minus 12x plus 22. And this guy actually is coming out to be really large. I'm starting with the negative numbers first. So you're doing, again, 2x squared minus 12x plus 22. Okay, so these numbers are coming out to be really large, as you can see. Okay, 36, which is still going to be beyond our grid values, so I'm not sure we'll be able to use any of those points. Let's see, with +4, we are getting 6. With 3, we're getting 4, so these numbers are good. 2 is giving us 6 again. Let's see, the number 1 will give us 12, and then of course if you did 0, you should get +22. All right, so let's see. I can use 4 and 6. So 4 and 6. 1, 2, 3, 4, 5, 6 will be right here. 2 and 6. 3 and 4. And then 0 and 22 would be somewhere over there. So really, these are the only 3 points that seem to be the ones we can use. And then our graph will basically end up looking something like this. Okay, so remember, this is the graph for either of those equations, and that's what that graph is going to end up looking like. Now, I know we were doing this for all our other graphs, so we'll continue doing that here and talk about the domain and range of this function. So of course, you've got the graph to help you out. Now you can see, since this is a parabola that's opening up, your domain values, which are the x values, will basically be, again, all real numbers, because this arm of your graph will keep going to the right. This arm of your graph will keep going to the left. So your domain is actually going to be from negative to positive infinity. Now, as far as the range is concerned, which is the y values, you will see that the lowest point of our graph is right here at +4, and then your arms are going up, right? Which means they're going towards positive infinity. So that means your range is starting at the number 4, and it's going to keep going up. So it's going to keep going towards positive infinity. Okay, so even as you're working through your homework examples and stuff, I would definitely ask you to practice with your domain and range so you are comfortable, working through those. So that's how you basically convert it from the standard form of your equation to the transformation form, and this is what your graph looks like. Okay. So that was example 1. Now you actually have a similar example here in example 2. You're given y equals 3x squared plus 4x plus 2, and then again they're asking you to convert it into the transformation form and then graph your function. So let's go here and look at example 2. So we've got 3x squared plus 4x plus 2. So just like you did in the previous example, the first thing you want to do is get that x squared by itself, which means we don't need that 3 as part of our x squared. So we're going to take that x squared out. I'm sorry, the 3 out. We're left behind with the x squared. Now, of course, 3 cannot be divided evenly into 4, right? Because there's nothing that you can multiply with 3 to get the answer 4. So what happens in this case is because 3 does not divide evenly into 4, you're actually going to leave it as a fraction, and then the plus 2 on the outside. So again, remember, we only do this with the first two terms, right? That plus 2 will stay as it is. So you've got 3 that we need to bring outside because I need my x squared to be by itself. And since 3 does not divide evenly into 4, you're actually going to leave that as a fraction as 4 over 3x. Then your next part is where we complete the square. So you're taking your expression, which is inside the parentheses, x squared plus 4 over 3x, and then you're trying to figure out what that last term should be. So remember, this is again the middle term divided by 2 multiplied into itself or taken to the second power. So this will give us your middle term b is 4 over 3. Now dividing by 2 is the same thing if you were multiplying by 1/2, and then you take a square. So take your middle term, 4 over 3, divide by 2, like I said, which is the same thing as multiplying by 1/2, and then square the whole thing. So if you just multiply across, you get 4 times 1, which is 4, 3 times 2, which is 6, to the second power. Now keep in mind, you always want to reduce your fraction. So 4 and 6 both have a 2 in common, so reduce it by 2, and you will end up getting 2 over 3, and then you can do a square. The other thing you could have done is right here, 2 goes into 4 twice, so you could have reduced it right here, and that would have also given you 2 over 3 squared. So either way, you can multiply first and then reduce it, or reduce it first and then multiply. You will get 2 over 3 quantity squared. So of course 2 times 2 is 4, 3 times 3 is 9, which means your missing term here is going to be 4 9s. Okay, so to complete our square, we have x squared plus 4/3 x plus, now we're adding the 4 9s. Now remember how we did it in the last example. To maintain the balance of your equation, if you're adding 4 9s, you also need to subtract 4 9s, and then you have that plus 2 on the outside. Okay, now for completing the square, or for our perfect square trinomial, we only need the first 3 terms, which means you're going to get rid of that minus 4 9s and bring it outside of your parentheses. So you should have left behind 3 in the front. Inside the parentheses, we'll have x squared plus 4/3 x plus 4 9s. And then now you are going to multiply this 3 in the front with the minus 4 9s in here. So let's do that here on the side as our scratch work. So that's multiplying 3 with negative 4 9s. If it helps, you can write that as 3 over 1. Again, you can multiply first and then reduce it, but when I look at this, I can see 3 goes in itself once, 3 goes into 9 3 times. So this actually reduces down to negative 4/3. So when you bring the number outside, it will become negative 4/3, which we will then add with the 2 on the outside. Okay. So I think we'll go ahead and add these two terms. So you are now adding negative 4/3 with 2. Again, write that as 2 over 1. Since we are adding fractions, you need to make sure you have a common denominator. So multiply this guy by 3. You get negative 4/3 plus 3 times 2 is 6. So this guy becomes 6/3. Negative 4 plus 6 is 2. So this will actually become 2/3. So coming back to our equation, you have 3 parentheses x squared plus 4/3 x plus 4/9. And then we are adding the 2/3, which we got from our addition of negative 4/3 with positive 2. Okay. The very last thing to do now is to factor our parentheses. So this guy is going to factor into a perfect square. It's a perfect square trinomial, so we know both our factors are going to be the same. So remember what I told you. Let's come back here to the top. So right here, when we were completing the square, you can see when we reduced our fraction, we got 2/3. So we had 2/3 right here. So we're actually going to take this 2/3 to help us factor our expression. So it's actually going to end up becoming x plus 2/3 the whole quantity squared. So it's whatever this number you have right here before you do the square to get your 4/9. That's the number that's going to help you factor this. So you end up with 3 parentheses x plus 2/3 to the second power plus 2/3. So this is where we took our standard form of the equation, which was 3x squared plus 4x plus 2, and converted it into the transformation form, which is 3 multiplied by the quantity x plus 2/3 squared plus 2/3. So this will become your final answer. Okay, so now they're asking us to graph this. So let's see what this graph will end up looking like. Okay. So let's see if we can do a table here again. So maybe -3, -2, -1, 0, 1, 2, and 3. And then we can basically see if we need to bring any more points. So again, I'm actually going to use the original form of the equation. So I will do 3 times x squared. Hold on a second. Plus 4x plus 2. Okay, let me make sure I got that incorrectly. So I've got 3. I'm starting with -3 squared plus 4 times -3 plus 2. So that's 17. So we won't be able to use that in our graphing. Now let's try this with -2. And with -2, we're getting 6, so that's workable. -1 will give us +1 as the y value, okay? Let's look at 0. And 0 will, of course, give you 2. Now with +1, we are getting 9. +2 is 22. So this is where we won't be able to use these numbers. And of course, 3 will also go higher. So we won't really be able to use those values either. So it looks like our good numbers are going to be right here. Okay, so let's see, at -2, we are at +6, so that's going to be 1, 2, 3, 4, 5, 6. -1, 1, 0, 2, 1, 9. So this graph, and I know it's kind of hard to see, is actually going to look something like this. Now, if you, you'll actually see this in the next section that we're getting ready to talk about, but when we talk about the vertex, which is going to be either the lowest or the highest point on your graph, depending if your graph is opening up or down. I think I just messed that up. Okay, well, not a great graph, but you get the idea. So when we talk about the vertex for this graph, you know what? I think I just made it worse. I think I'm just going to leave it there. Okay, so as I was mentioning, when we talk about the vertex, you will actually see that we can get the vertex of our parabola from these 2 points here. So I'm actually kind of using that point to get our lowest point on the graph, but don't worry about it because we're just getting ready to talk about it next. So you know the graphing, I know you guys can do that because we've done graphing extensively in the last chapter. I just want to make sure that you are able to convert it from the standard form to the transformation form. So I would ask you to definitely concentrate on this part, okay? Well, but there you go, there's the example too. Alrighty. So, you know, I mean, all of these are still parabolas. We're still talking about a quadratic equation here. So remember, you can always think of these equations or functions being transformations on the graph of f of x equals x squared function, right? So you can still use that idea of, are we moving the graph up or down? Are we moving the graph left or right? Is there a shrink or a stretch happening? Is there a reflection? So you can still use those same concepts that we used back in chapter 2 with transformations and try to use them here, okay? All right, so now let's talk about the opening, the vertex, and the axis of symmetry. So the opening basically depends on the value of A, and we had kind of talked about this a little bit when we were doing transformation. So the idea is if this value of A is going to be a positive number, your graph opens upward. If the value of A is going to be negative, your graph opens downward, because remember, that's where that reflection is coming into play, right? So positive A, graph will open up. Negative A, the graph will open down. And you can kind of see that in the graphs here. So your original function is f of x equals x squared. This is the gray function right here in the center. If your function is negative x squared, then of course your graph is opening downward, like you can see. Now with transformations, f of x equals a times the quantity x minus 8 squared plus k. Again, if a value is positive, your graph is going to open up. If a value is negative, then on the second graph, as you can see, your graph is going to open downward. So I would definitely ask you to read this paragraph. There's a lot of good information in here. I'm going to go over some of the highlights. So again, from our transformations, you should remember that the h gives you the horizontal translation. If the number h itself is positive, your graph moves right. If h is negative, your graph moves left, which means you go with opposite signs here in your x minus h quantity squared in your function definition. Now your k value, if k is positive, your graph goes up. If k is negative, your graph goes down, right? So we had talked about that when we were doing transformations. So they are saying due to these translations, the vertex or the point 0, 0 of your parabola will actually move. So if your h is making your graph move to the right and your k is making your graph move upwards, then that means that point on your graph is also going to move. So look at this graphs here again. So this is my point 0, 0 right here. So you can see when our graph moves to the right and goes up, this point also ends up moving. So instead of 0, 0, this point is now going to actually transform into HK. Same thing if your graph was opening downward, that point 0, 0. Again, you can see your graph is moving to the right and it's moving up. So again, that point changes to HK. So that's what they're talking about here. So depending on if your parabola is opening up, this will be the lowest point. If your graph is opening down, like here, it's going to be your highest point. And this is what we call as the vertex of your parabola, okay? So just depending on if the parabola is opening up or down, the vertex can be the lowest or the highest point depending on how your graph opens up, okay? Now, the other way that you can find the vertex of your parabola, especially if the equation is given to you in the standard form, is actually by using this equation right here for your x-coordinate. So you can use the little formula negative b over 2a, and that will give you the x value, put it back into your function definition, and you can calculate the y value. If your function is given to you in the transformation form, then you just have to look at your h and k values here to come up with the vertex of your parabola. So just depending on which type of form your equation is given in, you might have to use the formula negative b over 2a, or you can just look at the function and calculate your vertex. So that's what this little box here is talking about. For the quadratic function of the form f of x equals a, x minus h squared plus k, the vertex is going to be hk for this form. If the equation is given to you in the standard form, then for your x-coordinate, you use negative b over 2a. For the y-coordinate, you're basically taking this answer x and putting it back into your function definition, okay? So that's what this next example here is asking us to do. You can see this is an equation in the standard form for number 3, and they're just asking us to find the vertex of the quadratic function. So let's take a look at how we can calculate this. All right, so you are given 3x squared minus 12x plus 5. So to find the vertex, start by finding your x-coordinate, which uses this formula, negative b over 2a. So remember, this is our a value, this is our b, and this is our c. And of course, our formula does not use the c value at all. So you're doing negative b. Now remember, b also happens to be a negative number, which is negative 12. 2 times a happens to be positive 3. So 2 negatives will become positive. So that's positive 12 on the top. 3 times 2 is 6. 12 divided by 6 will of course give you 2. So that becomes our x-coordinate for the vertex. And now all you have to do is take this number 2, put it back into the equation, and find your y value. So for y value, we're going to take this number 2 here and put it back into our equation. So you will have 3x squared minus 12x plus 5, and then replace the x with the number 2. So you have 3 times 2 squared minus 12 times 2 plus 5. So let's clean that up. 2 squared, of course, is 4. 12 times 2 plus 5, and now you can multiply. So 3 times 4 is 12. 12 times 2 is 24 plus 5. Add all of that together and you're going to get negative 12 plus 5, which will actually give you negative 7. So our vertex is going to be positive 2 and negative 7. So basically positive 2 from here for your x value, negative 7 from here for your y value. And that's your vertex. So that's how that standard equation works. So whenever your equation is given to you in the standard form, this is how you are going to find the vertex of your parabola. Now, if you will notice, this a value here is a positive 3. So that actually tells us that our parabola will be opening up. And since our parabola will be opening up, your vertex is going to be the lowest point on your graph. So you can kind of use that to help you out also. Okay. Now, number 4, you will notice that the equation is given to you in the transformation form. So transformation, you don't have to do any calculations. You actually just have to look at your equation and see what that vertex is going to be. So let's go to number 4. So that's 1/2 times x plus 6 squared minus 1/4. So remember, this gives you your h value. This gives you your k value. So the vertex of your parabola, what happened? Excuse me. Oh, why is this guy not working? Okay, so remember your vertex is HK. Now, as I was telling you before, when you're looking at the value of H, always go with the opposite sign of what's given to you here in the parentheses. So since this is positive 6, that tells me our H value is actually negative 6. As far as the K value goes, you use the same sign that's given to you. So since this is negative 1/4, this will also be negative 1/4. So that's all you do is when the equation is given to you in the transformation form, the x minus h part is where, of course, you're getting the h value from. So if this is plus 6, that means 6 itself is negative. If this would have been negative 6 here in the parentheses, then your 6 would have been positive. So always go with the opposite sign for your h value. K will keep the same sign. So since this is negative 1/4, this will also be negative 1/4. And that's all you do when you're trying to find the vertex of your parabola from the equation in the transformation form. Now notice here, this 1/2 is your A value, and this is also positive. So that actually tells me that, again, this is going to be a parabola that opens up, and then your vertex is going to be the lowest point on your graph, okay? Alrighty. Okay, so again, I would ask you guys to read these 2 paragraphs here because it would make more sense for you to read it than me to read it to you. But basically, this is talking about the domain of your quadratic function. So keep in mind, as long as your parabolas are opening up or down, your domain is going to be the set of real numbers, which means it will be going from negative to positive infinity. Now, as far as the range of your quadratic function is considered, it will actually depend on the k value of your function here. So if your parabola is opening up and, excuse me, your k value, which is the second coordinate of your vertex, will actually be called as the minimum value of the function. You can see that right here. We call the minimum value, and that means the range of your function will go from k to infinity, including k. And then they're talking about the intervals where your function will be increasing and decreasing on, so you can kind of read that. Now, if your parabola is opening down, which means if a is negative, then your range will actually go from negative infinity to k, including k. K will now become the maximum value of your function, and then of course your increasing and decreasing intervals will also change. So make sure you kind of look through that. They're also talking about symmetry. So we know all parabolas are symmetry. If you just look at your x squared function, then we know it has symmetry about the y-axis. But you know, if you're going to move your graph horizontally to the left or to the right, then that actually means your axis of symmetry will change. And your axis of symmetry is actually going to be the same place where you calculated your vertex at. So that's going to be at x equals negative b over 2a. So it's that same formula that we use to calculate our vertex right here. So it's the same formula you use to calculate your axis of symmetry, okay? So let's see if we can put all of this into use by looking at our next example here. So this example is asking us to decide if the graph is opening up or down. They're asking us to find the vertex, the axis of symmetry, and the range of the function. They're also asking us to see if our function has a maximum or minimum value. And then they're actually also asking us to find the intervals where our function was increasing or decreasing. Okay, so let's take a look here at example 5. All right, so I've got the graph copied over here. Okay, so obviously, as you can see, they're asking us to find the opening of the parabola. So just by looking at our graph, you can see that this is a parabola opening up. So that's an upward opening, okay? They're asking us to find the next thing, the vertex of the parabola. So remember, that's going to be the lowest point on your graph, which is going to be right here. And looks like this point is at -1, -9. I don't know if you can read that point or not, but hopefully you can read it better on your own graph. Okay. The next thing they were asking us to find axis of symmetry. So remember what I said. Your axis of symmetry is going to be at the same value where your x coordinate for the vertex is. Because if you look at this, if I draw a vertical line here, I don't know if it's going to let me. Okay, not sure why it's doing this. There we go. So if I draw my vertical line through here, this is going to be your axis of symmetry. And you can see if we fold our graph along this line, the two halves will be the same, right? They're going to be coinciding with each other. So your axis of symmetry will always pass through the vertex of your parabola. And since this is a vertical line, vertical lines have the equation of the form x equals. So this will be x equals -1. So make sure whenever you're writing your axis of symmetry, you're writing it as an equation, x equals -1. Don't just write the number -1. Make sure you're writing it as x equals -1. So that's your axis of symmetry. Even though they didn't ask us to, we will go ahead and write the domain just so you're in the habit of doing that. So remember, this is a parabola opening up, which means your domain is going to go from negative to positive infinity. It's going to cover all the x values on your x-axis. They are asking us to find the range. So of course, you can see your graph starts here at -9 and then it goes up. So your range is starting at -9, including -9. And since your graph is going up, that's going towards positive infinity. Okay. And you can kind of verify that from here. Remember when we said your graph was opening up, a equals 0, then your range was going from k to positive infinity, including k. So that's the same thing we had, including -9 and going up to positive infinity. Okay, so that's your range. Now they are asking us if we are going to have a maximum or a minimum value. Since this is a parabola opening up and my vertex is the lowest point on the graph, which means we have a minimum value. And the minimum value is again going to be this -9, the k value, okay? So minimum value is -9. And then the very last thing they wanted us to find were the intervals on which the function was increasing or decreasing. So the function is increasing on which interval, and the function is decreasing on which interval. Now keep in mind, guys, when we are talking about intervals for increasing and decreasing, we are always talking about on which x values is this increasing and decreasing thing happening. So you can go back and look at your notes here. You can see when we're talking about decreasing and increasing, we're talking in terms of the x value, right? So that's the h from your function or the h from your vertex. So it's decreasing on negative infinity to h. It's increasing from h to infinity. And you can kind of verify that here. So this left part of our graph, you can see the values are going to go down, right? Your y values are getting smaller. So that's the portion where our graph is decreasing. So it's decreasing on this side. It's increasing on this side. So you're decreasing from negative infinity and you stop right here at the vertex, which is at -1. And you are increasing starting here again at the vertex, -1, and then you're going to the right, which is positive infinity. So you're increasing from -1 to positive infinity. Okay, so those were all the different properties, I guess, of the parabola that they were asking you to identify. Okay, so let's go back to our example here. Now we're going to be doing the same exact thing in example 6 and 7, but in here, they're not giving you the graph, but they're giving you the equation of the function. So of course, that means you start by finding your vertex first, and then using those values, we can come up with all of these other properties or characteristics. So they're asking us to identify all the correct characteristics of the parabola. So let's start by finding our vertex, for example 6 first. So here's example 6. You've got y equals 3 times the quantity x minus 5 squared minus 4. So let's talk about the vertex. So remember, your vertex is the h and the k value here. So now inside my parentheses, I have x minus 5. So remember, you go with the opposite sign. So since it's negative, that means 5 itself is positive. For the k value, you keep the same sign. So it's -4. This guy will stay -4. Okay? So let's talk about the opening next. So our a value here is a positive a. So since a is positive, that means our graph is opening upward. Okay, we've already got our vertex. So let's talk about the axis of symmetry. Now remember, your axis of symmetry passes through your vertex. So that's going to be x equals the x coordinate, which is 5, x equals 5. Since this is a parabola opening up, and you can do a little rough sketch if it helps you. So this is a parabola opening up. We know the vertex is going to be the lowest point on our graph. So when we're talking about the range, your graph is starting at -4 and it's going up to positive infinity. So your range is going to go from -4 to positive infinity, including -4. So that's the range. Again, since this is a parabola opening up and our vertex is the lowest point, which means you are going to have a minimum value for your function. And that minimum value, of course, is going to be at the y coordinate for your vertex, which will be -4. And then the very last thing, as far as your characteristics go, we want to talk about the intervals on which your function is increasing and decreasing. So the interval that our function is increasing on and the interval on which our function is decreasing. Okay, so again, this graph can kind of help you out. Remember, this is going to be with respect to the x values. So again, on the left-hand side, this portion right here is where your function is decreasing. So that's going to be from the interval -infinity 2, 5. And then on this side, on the right-hand side of your graph is where it starts increasing. So that will go from 5 to positive infinity. Okay, so this is how you would go about if your equation was given to you in the transformation form. Start by finding your vertex. You can start with the opening also, but once you have the vertex, then you can get your axis of symmetry, you can get your range, the minimum value, and the intervals on which your function is increasing and decreasing. And again, since this is a parabola opening up, your domain for this function would be going from negative to positive infinity. Okay, so that's number 6. Now the number 7 is of course given to us in the standard form, right? So you can still come up with the opening, but for the vertex, we're actually going to have to use the formula. So let's go ahead and do that part first, calculate our vertex, and then we'll come back and talk about the other characteristics. So let's look at example 7 here. F of x equals negative 2x squared plus 6x plus 9. So let's talk about finding the vertex first. So remember, for your x coordinate, you use the formula negative b over 2a. Again, this is our a, this is b, this is c. So negative b is positive 6. 2a, a is negative 2. So that would be negative 6 over negative 4. 2 negatives become positives. 6 over 4 can be reduced down to 3/2. Okay. Excuse me. So now that we have our x coordinate, let's find the y. So remember, for the y, you're putting it back into your equation. So this would be negative 2 times 3/2 squared plus 6 times 3/2 plus 9. So 3/2 squared would be 3 times 3 is 9, 2 times 2 is 4. I guess I'm going to leave it as it is for now. Now you can reduce these numbers if you like. If you want to leave them as fractions, you can do it that way. It's up to you, but I can see that 2 here will go into 6 3 times. This 2 here will go into 4 2 times, so you can kind of reduce those. So on the first one, I'm left with this negative on the outside, 9 over 2, after we got rid of those common terms, plus I have only left with 3 times 3 on my middle term, so 3 times 3 will become 9, and then the plus 9 from the end. So that's negative 9/2 plus 18. Again, find a common denominator, and you can go about it that way. Multiply by 2. And of course, at this point, I'm assuming you know how to add fractions. Okay? So I'm adding negative 9/2 with 36 over 2. And what does that come out to be? Okay, so 9 taken away from 36 will give you 27. That's 27 over 2. So that's my y coordinate. And the vertex now comes out to be 3/2 for the x value, 27/2 for the y value. And again, I would leave them as fractions. Don't convert them into decimal unless your instructions say decimal answers are okay. If it doesn't, then leave your answers as fractions. And most of the time, they do want you to leave it as fractions. Okay, so we have our vertex. Let's talk about the opening. So again, for the opening, you can see our a value here was negative 2. So since it's a negative value, you know what that means. your parabola is going to be opening downward, right? Because it's negative. Or basically you can think of that as the negative is causing a reflection to happen. So we've got our opening, we've got our vertex. Now you can talk about the axis of symmetry. Remember again, your axis of symmetry is passing through your vertex, through the x coordinate, so that will be x over 3/2 as your axis of symmetry. Okay. We can talk about the range of this function. So remember, this is a parabola opening down. So again, if you want to do a little visual, this is our vertex here at 3/2, 27/2. So since this is now a parabola opening down, so that means your range will actually be going down to -infinity, and then we'll be stopping at the y coordinate, which is your 27/2, including that number. So basically you're coming down from -infinity and stopping at 27/2. Okay, so that's your range. Now the next thing they want to know is, do we have a maximum or a minimum value of the function? So this one here, since your parabola is opening down and your vertex is going to now be the highest point of your parabola, that actually means you are going to have a maximum value, right? And again, that maximum value is going to be at the y coordinate of your vertex, which is at 27/2. Okay, so this is our maximum value of the function. And then of course, the last thing we want to talk is about the interval on which your function is increasing and the interval where the function is decreasing. So you can see this is a parabola opening downward, which means your intervals are actually now going to switch. So here on the left-hand side, you can see my graph is actually going up. So it starts out with smaller y values and then the y values get larger, which means on this side, our function is increasing. So remember, again, these are in terms of x values. So you are coming from -infinity and you're stopping at 3/2. So it's increasing on the interval from -infinity to 3/2. So once you get to 3/2 right here at the vertex, then your graph starts decreasing because now your y values are getting smaller. So on the right-hand side, your function is decreasing, which means we're now going from 3/2 to +infinity, where your function is decreasing. Okay? And again, guys, since this is a parabola opening down and not on its side, your domain is going to be from negative to +infinity. So you can kind of see what happens when the function is given to you in the standard form. You first find your vertex by using x equals -b/2a. Find the x value, then take that answer, put it back into your function, into your equation to find the y value, and then the x and y value will become the vertex of your parabola. And then once you have those numbers, you can come up with all of the other characteristics. Okay, so here, this is your example 7. Okay. Now, the next thing we want to talk about is the intercepts. Now, we have done intercepts in chapter 1. Can't remember if we talked about them in chapter 2, but we did talk about them in chapter 1. So intercepts is basically where, you take the x value, set it equal to 0 to find the y-intercept. You take the y value, set it equal to 0 to find the x-intercept. So this is actually the same equation that we did here in number 6. 3 parentheses x minus 5 squared minus 4. So now they're actually asking us to find the intercepts and then sketch the graph of the parabola. So you can actually go back and use all the characteristics that we already came up with in example 6 and use that to your advantage also. But let's start by finding the intercepts for number 8 here. Okay. So let's start by finding our x-intercept, which is where we need to make our y value 0. Okay, so making y value 0, which means we set our equation equal to 0. So you're basically trying to get x by itself. I guess I'm going to start by moving the 4 to the other side. So go ahead and move that 4. You end up getting 0 plus 4, which is 4, equals 3 times x minus 5 squared. So of course now we need to get rid of the 3. So let's go ahead and divide both sides by 3 here. And we end up getting 4/3 equals x minus 5, the whole quantity squared. So of course, since you can see we have a square on one side, we need to get rid of the square. So we will go ahead and use square root on both sides. Anytime you use a square root, remember you get one positive and one negative root. So here your square root and square will cancel out, giving you x minus 5 on the right hand side. And we're actually going to need to simplify our square root of 4/3. So I know square root of 4 is 2, so you can actually go ahead and get 2 over square root of 3. But if you'll remember from our discussion before, we cannot leave radicals on our denominator. So this is where we'll need to rationalize our denominator, which means multiply both the numerator and denominator by square root of 3. That will give you 2 times square root of 3/3. So this is how you need to clean the left-hand side of your equation here. So this will give us plus or minus 2 square root of 3/3. And then the very last thing we got to do is get rid of that 5. So add the 5 on both sides. Right, so that cancels out. You're left with x on one side. And then you are left with plus or minus 2 square root of 3/3 plus 5. So your x-intercepts will actually come out to be 2 square root of 3/3 plus 5, comma 0, and negative 2 square root of 3/3 plus 5, comma 0 for the second x-intercept. So of course you can see we have 2 x-intercepts. Now since this, as far as writing your x-intercepts goes, this would be your final answer. But since they are asking us to graph, let's find their decimal approximations. So we've got 2 square root of 3 divided by 3, and then you're adding 5 to it. So this first part is coming out to be approximately, and I'm going to round this to 2 decimal places, 6.15. And then let's do it again for the minus 2 square root of 3/3 plus 5. And this is coming out to be approximately 3.85. So this will actually help us when we are graphing our quadratic function here. So this was our x-intercept. Now let's find the y-intercept. So remember, for the y-intercept, we make our x value 0. So that would be y equals 3 times 0 minus 5 squared minus 4. So that would be 0 minus 5 is negative 5 squared. Negative 5 times negative 5 is positive 25. Multiplied by 3, which is 75 minus 4, which comes out to be 71. So 0 71 is your y-intercept. Not an easy number to graph, is it? Okay, so this is the information we got from number 8. Now remember, you have all that other information from number 6. So let me go ahead and write that here. So just to show you, right here in example 6, we've got our vertex, our opening, axis of symmetry, range, domain, minimum value increasing and decreasing on. So vertex is 5, -4. We know it's opening upward. Of course, your axis of symmetry passes through the x coordinate of our vertex. So that's x equals 5. Domain, of course, we know is all real numbers. Range is going to go from -4 to infinity. It had minimum value at -4. It's increasing on the interval 5 to infinity, decreasing on the interval -infinity to 5. And again, this is just all the information we have from example 6 here. Okay, let's see what all of this information can be used to come up with the graph of our function. Oops. Okay, didn't work out the way I wanted it to. Okay, so let's see, our vertex is at 5, -4, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so at 5, -4. Okay, let me try that again. Right? 5, -4 is going to be our vertex. Now, so I'm using this point right here. Now, 0, 71, of course, is going to be too far out from our scope of our grid, right? So we actually will not be able to graph this. And then our x-intercepts are going to be approximate values because you have them at 6.15 and 3.85, right? So they're basically just a little before the number 4 for the smaller value and just a little after the number 6 for the larger value. So 6 and a hair. Let me see, maybe I'll use a different color here. Okay, so just a little after 6, I'm going to have one of my x coordinates, and then just a little before 4, again, just a hair before 4, I am going to have my other x-intercept. So you have your vertex, which remember is going to be the lowest point of your graph, and then going through your x-intercepts, and I'm not sure I want to do it like that. Let me see. Okay. And then we know at 0, 71, so somewhere right here above on your y-axis, you would be crossing at 0, 71. But this kind of gives you a rough idea of what the graph for this function is going to look like. So you can see this is opening upwards. If you drew an axis of symmetry that would be going through x equals 5. So it would be a vertical line going right through here. You can see we have a minimum value at -4. The range goes from -4, since it's going up, to positive infinity. Domain is, of course, negative infinity to positive infinity. And then you can see you're increasing, decreasing intervals. It's increasing from 5 to infinity on the right-hand side, and then it's decreasing from negative infinity to 5 on the left-hand side. So this is what your graph will end up looking like. And again, if you want to visualize it, you can kind of draw your axis of symmetry through the vertex. Okay. Alrighty, so that's basically what they wanted us to do for example 8 here. Pretty much the same kind of thing is happening on example 9. You know what you can do is just pause the video, go ahead and try doing example 9 on your own, and then you can come back and look at the video and see, hey, did you do it the right way or not? So that might be a good practice for you to look at, okay? Okay, so number 9 is x squared equals 6x plus 9. So this one, I don't think is an example we have done before. No, it doesn't look like it. So we'll actually need to come up with all the values, but let's go ahead and start with finding our x and y intercepts, and then we can find all the other characteristics. So let's start with our x-intercepts. So again, that means making our y value 0. So you're basically solving the quadratic equation here. You can use the quadratic formula. You can use factoring. Of course, you can use completing the square. I'm actually going to go with factoring because this is actually a perfect square trinomial. But if you don't want to use factoring, you can try the quadratic formula. So if you look at this, and let's do this here on the side, you're finding two numbers that multiply to give you 9 and add up to give you 6. So if you look at that, oops, it's actually going to be positive 3 and positive 3. 3 times 3 is 9. 3 plus 3 is 6. So this guy actually factors out into x plus 3, or basically x plus 3 squared. Like I said, it's a perfect square trinomial, and this is equal to 0. So even if you take the square root on both sides, since 0 does not take a positive or a negative sign, you actually just end up getting 0 here. Square and square root cancel each other out, leaving you with x plus 3. So all we do is subtract 3 on both sides, and you get x equals -3. So that's our x-intercept, -3, 0. In that same way, we can find the y-intercept by making the x value 0, right? So that will be y equals 0 squared plus 6 times 0 plus 9. So these guys, that's a 0, that's a 0. You just left with 9. So 0, 9 becomes your y-intercept. So not too bad. We've got our x-intercepts and our y-intercepts. Now let's look at what the vertex of this parabola is going to be, so we can find all our other characteristics. Remember, for the vertex, you can use x equals -b over 2a. So your a value is here, which actually just happens to be 1. This is b. This is c, which we don't really need the c. So let's see, -b. b is positive 6. 2 times a is positive 1. So that's basically -6 over 2. which is -3. That's your x value for the vertex. Put that back into the equation to find the y value. So that's going to be -3 squared plus 6 times -3 plus 9, which actually comes out to be -3 times -3 is +9. 6 times -3 would be -18, and then plus 9. So you've got 9 minus 18 plus 9. When you add all of them together, you actually end up getting 0. So your y, y coordinate is 0. So the vertex for your parabola is at the point -3, 0, which also happens to be your x-intercept, because that's the exact point we got here, right? -3, 0, -3, 0. So this also happens to be your x-intercept. Okay, so we've got our vertex now. Now your a here is a +1 value. So since a is positive, that means we know that our parabola is going to be opening upward. And then let's see, we can calculate our axis of symmetry, which of course passes through the x coordinate of your vertex, right? So that's x equals -3. Let's see, what other things did we find? You can talk about the domain. So the domain, since this is a parabola opening up, it's going to be negative to positive infinity. Range, again, since parabola is opening up, you are going from 0 to infinity. Again, parabola is opening up, which means we have a minimum value at 0. And then the interval on which your function is going to be increasing and decreasing on. This is again a parabola opening up, so it's going to be increasing from -3 to infinity and decreasing from -infinity to -3. Alrighty, so all we got to do now is graph our function here. Okay, so our x and y coordinates. Let's do our points. 1, 2, 3, 4, 5, 6, 7, 8. I don't know if we need that many. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's use all the points that we have. We've got our x-intercept, which also happens to be our vertex at -3, 0. So that would actually be right here. So your graph is basically sitting on top of your x-axis. Okay, let's see. Our y-intercept is at 0, 9. So I don't think I did 9, did I? Okay, I'll need to bring in another point here for our 0, 9. You guys have a 10 by 10 grid on your handout, or if you're drawing this on a notebook, then you can make sure you have at least 9 points on your positive y-axis to get this graph. Okay. Now, here's the thing. We know a parabola is symmetric, right? Because we have the axis of symmetry. So from -3, if I'm going 3 units to the right, I have my point 0, 9. So in that same way, from my vertex, -3, 0, if I go 3 units to the left, I will actually have a similar point. So at -6, I will also be, at -9. Let's make sure they're in the same line. Okay, and then you can draw your parabola like that. And if it helps you and you need to have a few more points, you can actually do a table And you can do -6, -5, -4, -2, -1, and 0 as your x values. Put these numbers into your equation and calculate the y values for them. So you've got x squared plus 6 times x plus 9. So you will get 9 here, which is what I was talking about as our point of symmetry here, because this point here is -6, -9. This point here was 0, 9. This point here, of course, is -3, 0. If you do -5, you have 4. At -4, you have 1. -3 we know has to be 0, but again, you can try that if you want. -2, I'm going to say should be 1. And then -1 should be 4. And then, of course, at 0, you will be back at 9. Okay, so you can use these points also to help you out. I'm not sure if my graph will show these. Let me try. Okay. So let's see if I use these points, I might hopefully get a little bit of a better shape. So -5 is at 4. -4 is at 1. This guy is at 1. He's at 4. 0, 9. So there we go. Those should be all our points. Whoa. Okay. So something like this. This is not kind of going how I want it to. Something like that. And then this is our function y equals x squared plus 6x plus 9. And again, if you did your little axis of symmetry, this is what it would end up looking like. And then again, you can verify all of these characteristics here. Of course, we know our parabola is opening up. Vertex is at -3, 0, which also happens to be our x-intercept. Axis of symmetry is going through x equals -3. Domain is, of course, all real numbers, negative to positive infinity. Your range is starting at 0, going up to positive infinity. Our minimum value is at 0. It's increasing on the interval from -3 to infinity, decreasing from -infinity to -3. So you should be able to verify all of those characteristics here for example number 9. So again, we started out by finding our x and y intercepts. Then we came back and found our vertex and then all of the other characteristics. And then using a table, you can graph your function. Okay. Okay, so just some information here about, they're basically talking about the x-intercepts will be on the opposite sides of the graph and they should be the equal distant from your axis of symmetry. Excuse me, so you should have seen that actually here on example 8. Example 9, since you only have one x-intercept, they actually don't end up being on opposite sides of your axis of symmetry. And then as I was telling you earlier, to find your x-intercepts, you can also use the quadratic formula, which is given to you right here. So you can use that, okay? So that was talking about the different characteristics and graphing of our quadratic functions. Now we're actually getting into how to solve quadratic inequalities here. What happened? Okay. Let me see what happened, why we're not able to see the bottom half of our. Alrighty, here we go. So let's look at the quadratic inequalities now. So we've talked a little bit about solving inequalities in the previous two chapters. So let's take a look at how quadratic inequalities work. Of course, we're still talking about a second degree or a quadratic polynomial here. So you might have an inequality that looks something like this: ax squared plus bx plus c greater than 0. So here you can actually use the graph of the quadratic function to help you come up with how to solve the inequality. So they are telling us that the values of x that satisfy the inequality are the same values of x for which y will be greater than 0 for the graph. So basically you are going to graph your quadratic function, which is y equals ax squared plus bx plus c, and then you're going to be looking at, are they asking us for a greater than inequality, a less than inequality, and then based on that we can use the graph of our function. So you can kind of use this method right here for helping you solve the inequalities using the graphical method. So like we did with quadratic functions before, you want to get 0 on one side, get the entire quadratic polynomial on the other side. Now, when they're saying find all the roots to the corresponding quadratic equation, by roots, they mean you can find your x-intercepts. You can also think of them as being the solutions for your quadratic equation. So you're basically solving the quadratic equation to find the root, or as I said, think of them as finding the x-intercepts. Then graph your quadratic function. The roots will determine your x-intercept. So that's kind of what I was talking about. And then of course you're looking at the graph to read the solution of your inequality. So let's look at this example here. They're asking us to solve the inequality and then write the solution in interval notation, and they're also asking us to graph it. So you've got x squared minus 2x is greater than 8. So remember what they said, get 0 on one side. So the first thing we're going to do is get our quadratic inequality in, I guess, what I would call as the standard form. So let's start by subtracting that 8 and bringing it to the left-hand side. So you should have x squared minus 2x minus 8, and this will now be greater than 0. You only subtracted 8, right? So nothing has to change. The greater than symbol will stay the same. Okay. Now, they're asking us to find the roots, right? So finding the roots would of course mean you can use factoring or you can use the quadratic formula. But this one again is a pretty simple expression that you can find the roots for. So what I'm actually going to do is, let me see. So this is the inequality we're going to solve, but let's write this as a quadratic function. And then to find the roots, I'm actually going to factor this. So again, you're looking for two numbers that multiply to give you -8, and add up to give you -2. So two numbers that multiply to give you -8 and add up to give you -2. So the two numbers that of course give us 8 are going to be 4 and 2, but I'm looking for -8, which means one of these numbers has to be negative, and they have to add up to -2, which means the larger number has to be negative, the smaller number has to be positive. So it should be -4 and +2. So these guys will be x minus 4 and x plus 2. And think about it, when I multiply these two, -4 and 2, I get -8. When I add -4 and +2, I get -2, right? Alrighty. So if I set these guys equal to 0, I will have my x-intercepts or my roots. So that's going to be x minus 4 equals 0 or x plus 2 equals 0. this guy here will give me positive 4. And this guy here will, of course, give me negative 2. So these are our intercepts. Okay, so let's go back to our steps. So we found our roots. We, of course, got our inequality with 0 on one side and the quadratic polynomial on the other side. Now they're asking us to graph the function and then, of course, use those x-intercepts to help us out too. So let's go ahead and graph this guy. And whoa, I don't know why it keeps doing that. Okay. Alrighty, there we go. Okay, so we've got our x-intercepts at 4, 0 and negative 2, 0. Of course, it would help to find the vertex of our parabola here. So let's find the vertex. Remember, that's x equals negative b over 2a. So that's going to be negative, and my negative b is negative 2. 2 times a, there's no number here, so we know that's going to be a positive 1. So negative and negative becomes positive 2 on the top. 2 times 1 is 2. So that's my x coordinate, x equals 1. And then find the y, which would be 1 square minus 2 times 1 minus 8, which is 1 minus 2 minus 8. And what does that come out to be? Negative 9, right? So that's our y. Alrighty, so let's graph that guy, which means I'm actually going to need more points. This was 6, 7, 8, 9. So your vertex is at 1, negative 9. Okay, and then of course these guys would be passing through your x-intercepts. It would actually help for us to know what our y-intercept is, so I can see where I'm supposed to cross the graph here. So let's find the y-intercept, which means we make our x value 0. So that's going to be y equals 0 squared minus 2 times 0 minus 8. So your y-intercept is at 0, negative 8, which would be right here. So now we can get our graph completed. And there you go. This is kind of what your graph would look like. I think I've made it a little fatter than I wanted it to be. Okay. There you go. So this is the graph for y equals x squared minus 2x minus 8. So getting the graph was our main goal, right? Now, after you have found the graph, we are actually back to this guy. Now here, they're basically saying, where are your values going to be greater than 0 for this function? So if you look at the graph here, anything above the x-axis is where our values are going to be positive. So right here, all our y values are going to be greater than 0. Right here, all our y values are going to be greater than 0. If you look at this part of our graph here, from the vertex to the x-intercept, this portion here, all my y values are negative, right? So they are less than 0. Same thing here, between the vertex and the X-intercept, all of these y values are going to be less than 0. Right at the X-intercepts, your y value is equal to 0. So basically that's what they're asking us to do, is look at the graph and then identify on which interval, now you're still using interval notation here, on which interval is your graph going to have y values that are going to be positive, right? Because this is a greater than 0 inequality. So the greater than 0 is this portion, which on the interval will go from -infinity to -2, because that's what this guy was here, -2. And then this interval here is starting at 4 and going to +infinity. So your solution set is actually going to be from -infinity to -2 union, because they're two separate intervals, from 4 to infinity. Okay. And then if you were graphing your solution set, you would have -2 here, 4 here. Again, you're not including the endpoints. So this is parentheses from -4 to infinity. And then again, not including -2 from -infinity to -2. This is what your interval notation would look like. And I guess 0 could be somewhere over here. Okay, so let's do a quick recap on this. We started by getting our 8 to the left-hand side. So we got 0 on one side, your polynomial on one side. Then think of this as being your quadratic equation. So y equals x squared minus 2x minus 8. I factored it to find my x-intercepts. So remember, these guys were our x-intercepts, or roots as they're calling it. Then to graph our function, I found the vertex and I also found the y-intercept. And then using our two x-intercepts, the y-intercept and the vertex, we came up with the graph of our polynomial. And then since our inequality was asking us, where are your y values? Because remember, all of this equals y, right? Because that's how we defined our quadratic equation as. So this part here equals y. So they're basically asking you, when is y greater than 0? And y was greater than 0 on this side, and y was greater than 0 on this side. So that was the interval -infinity to -2 and 4 to infinity, and you use the little union symbol to combine them together, and the graph of your solution set would look like this horizontal line right here. Okay. Now number 11 is actually a continuation of the same polynomial. You can see it's x squared minus 2x, but now it's less than equal to 8. So it's actually the same exact polynomial as number 10, but they're changing the direction of your inequality symbol. So you can actually use the same graph that we have for number 10 and come up with the solution for number 8. So I'm going to use the same graph. So let's do number 11 here, which is x squared minus 2x less than equal to 8. Again, go ahead and get that 8 to the left-hand side. So you have x squared minus 2x minus 8, but now this is less than equal to 0. So remember, again, this would be y is less than equal to 0. You know what? I think I'm going to use a different color here. So y is equal to 0 right here at the x-intercepts, right? And y is less than 0 on this part of our graph. So all of this portion here is what you would be including for y less than 0, y less than 0, and then y equal to 0, and y equal to 0. So it's basically going away from this interval that you had in number 10. So you would actually say for your solution set here, and since this guy is also including 0, that means you're going to be including your endpoint. So it's actually going from -2 here to +4 here, because at -2, our y value is 0. And then between -2 and 4, we have all the negative y values, which is less than 0. And then back at +4, my y value is going to be 0 again, right? So this is actually going from the interval -2 to 4. And because of that equal to sign, you are including your endpoints. So this is actually going to be, like I said, right in between this, and then your graph, of course, will look like this. So you're going, let's say, from -2 to +4, and you are including everything in the middle. Whoa. Okay. Redo that because I made a hot holy mess. There we go. All right, so this is our line going from negative to positive infinity, 0 in the middle, -2 here, +4 here. Since we're including the endpoints, we're going to put brackets and then everything in the middle. So that's going to be your graph for your solution set. Okay. So look through these two examples, and then, of course, let me know if you've got any questions. Now, using a graph is okay. I mean, obviously, we do a lot of graphing, but we know a graph is not always going to be the most accurate thing, and also some of the important things could easily be missed on a graph. So a graph is not always going to show you all the important features. So we usually don't want to use a graph to make our conclusion just based on that. So we actually prefer using what we call as the test point method. And test point method, you don't have to do anything on a graph. You actually just use your x-axis, the number line, and that number line can actually help you decide where your y values are going to be positive, where your y values are going to be negative, where they're going to be 0, which we know they're going to be 0 where they have the roots or the x-intercepts at, right? And then you can actually use the test point method to come up with in which interval your graph's going to be greater than 0, which interval is going to be less than 0 or equal to 0. So let's go through these steps here of solving the inequality using the test point method. So same thing, start by getting 0 on one side, move your quadratic polynomial to the other side, find all the roots. So remember, when we're talking about roots, we are talking about x-intercepts. Okay. Now, once you have your roots or your x-intercepts, you plot them on a number line. And then from each interval that is separated by the roots or the x-intercepts, from each interval, we actually select the test point. We put that test point back into our quadratic equation, and we see, do we get a positive or a negative sign from that? And then based on that, we can actually come up with the result for our quadratic inequality. So let's take a look at how exactly does this test point method work. And I think you might like it better than the graphing method because you don't have to worry about graphing. And I think it's a lot easier and goes a lot faster than using the graphical method. So let's take a look at this test point method here for number 12. So our example is x squared minus 2x minus 4. So remember again, the first process for us is finding our roots or our x-intercepts. So this is where we would take our quadratic function, x squared minus 2x minus 4. Now, this expression, x squared minus 2x minus 4, cannot be factored. You can try factoring, but factoring actually does not work in this way. So we are going to use our quadratic formula, because that will get us to our roots a lot faster. So here's your quadratic formula, negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so again, remember, this is your a value, this is your b, this is your c. So that's negative of b, so that's negative of negative 2 plus or minus inside the square root. You've got negative 2, the whole quantity squared, minus 4 times a, which is 1, times c, which is negative 4, and then the whole thing divided by 2a, which is 2 times 1. So negative times negative will become positive, so that becomes a positive 2, plus or minus, inside your square root, negative 2 squared, that's negative times negative, which is positive, so that becomes positive 4. And then I am multiplying negative 4 times positive 1 times negative 4. So basically multiplying negative times negative, which is positive, 4 times 4, which is 16. So I didn't need that whole thing. Over 2 times 1, which is 2, right? So this becomes 2 plus or minus square root of 20 over 2. Now remember, you need to simplify square root of 20. So I can write square root of 20 as 4 times 5. And that will, of course, become 2 plus or minus square root of 4 is 2. So that comes outside. 5 will stay inside the square root. And the whole thing, of course, is divided by 2. So you should notice that you have a 2 and a 2 on your numerator. You can actually bring that 2 outside as your greatest common factor, which leaves you with 1 plus or minus square root of 5. And then we also have a 2 on the bottom. So by doing it this way, if you factor out the 2 from the numerator, you can then actually cancel these guys out, and you are left behind with 1 plus or minus square root of 5. So it's actually easier to clean it up this way. So again, just take by factoring this common 2 outside, which leaves you with 1 plus or minus, because you got to put a placeholder for this 2 in the beginning. That's where we put the 1. This 2 is gone from the second term, leaving you behind with the square root of 5. And then 2 from the top cancels out the 2 from the bottom, leaving us with 1 plus or minus square root of 5. Okay? And then as your x-intercepts, they will be 1 plus square root of 5, 0, and 1 minus square root of 5 and 0. Now, once you find your x-intercepts, then remember we put this on a number line, and we may actually need decimal approximations of this number so we know which test points we need to select. So your 1 minus square root of 5 is going to be smaller than 1 plus square root of 5. But let's see what these decimal approximations are, because without them, we will not be able to select our test points. So approximately 1 minus square root of 5 is approximately 1 point, looks like 24. And 1 plus square root of 5 is approximately 3.24. So you can see these were not nice, clean, happy numbers. So that's why we couldn't have factored these. So what's happening now, this is our basically our x-axis, and these x-intercepts are dividing our x number line, our x-axis, into 3 intervals. So I need a test point from this side, I need a test point from this side, and I need a test point from this side. And remember, this is where we're going to positive, here we're going to negative infinity. So anything which is smaller than negative 1.24, you can select that. Anything which is greater than 3.24, you can select that. And then of course it's up to you what numbers you want to use. So you can, if you want, and I'm going to do this, I guess, in green, you can use 0 as your test point here because 0 falls between negative 1 and 3. You can use, I guess, negative 2, which would be smaller than negative 1.24. And of course, you can use positive 4 for a number larger than 3.24, right? So those will be our test points. Now, what you're going to do is you're going to take each of these test points, you are going to put it into this quadratic equation here. And we're really interested in seeing, are we getting a positive or a negative answer when we put this in our quadratic polynomial? So your quadratic polynomial is x squared minus 2x minus 4. So let's start with x equals negative 2. So let's see, this will come out to be negative 2 squared minus 2 times negative 2 minus 4. And looks like this is giving us a positive 4 answer. So this is a positive sign here, which means what this is telling us, that from negative infinity to 1 minus square root of 5, all your y values here are going to be positive. So that means your y values are going to be greater than 0. Right at the x-intercept, your y value is equal to 0, okay? Now let's see what happens for our second test point, which is x equals 0. So same thing, put it into your equation. And as you can see, this will end up giving us negative 4, so that's a negative sign. So that means all the y values here are going to be less than 0. And then our last test point was x equals 4. Okay, so let's see, what do we get with positive 4? Oh, we're getting a positive 4 for this guy. So that's a positive sign, which means all our points here are again going to have y values greater than 0. Okay, so this is kind of how the test point method works. Use your x-intercepts to break your interval down into 3 intervals, because we had 2 x-intercepts. This breaks down into 3 intervals. And then use a test point from each interval and then see where you're getting a positive and a negative sign. Now let's go back to our inequality. This is asking us, where is your y value going to be less than 0, right? It's not less than equal to, it's just less than, which means you are looking at this section where we have negative signs. So that's going to be the interval between these 2 x-intercepts. So when you write your solution set down, it is going to be between our 2 x-intercepts, but not including the endpoints. And then again, if you had to graph your solution set, this would be between 1 minus square root of 5 and 1 plus square root of 5. Again, not including the endpoints. So parentheses. And then you would shade the middle part. So again, guys, since your interval was less than or equal to 0, that's why you were finding where you had negative signs, and that happens to be between your two x-intercepts. So it's going to be the interval between these two x-intercepts, and that's what we have as our solution set. So you can see the test point method is pretty straightforward. Find your x-intercept. So if you need to use the quadratic formula, or if factoring works, you can do that. Use those two x-intercepts to break your x interval or x-axis into 3 intervals. From each interval, pick a test point, put it back into your equation, x squared minus 2x minus 4, each of those test points. See what signs you are getting, positive or negative. Put it on your number line accordingly, and then looking at your inequality, you will know which interval you need to go with. Okay, so this is how you use the test point method to solve a quadratic inequality. Okay, so we were talking about how our parabolas or quadratic functions have a maximum or a minimum point, right? Remember, that's where your vertex is the lowest point, you have a minimum, your vertex is at the highest point, you have a maximum. So they're actually using that idea for applications. So you can often solve applications where they're asking you to find the minimum cost, or how you can minimize your cost, or how you can maximize the profit, maybe even in terms of maximizing the area. So the idea is you basically need to find the vertex of your quadratic function, and then the y coordinate will actually give you that maximum or minimum value. So this first application we're looking at is talking about maximizing the area. So they are saying Chandra wants to enclose a rectangular garden with 200 yards of fencing. What dimensions for the garden will maximize its area? So basically, if she has a rectangular garden, she has 200 yards of fencing, she wants to know what the length and the width of her garden should be so that she can get the maximum area out of this space. So let's take a look at this example here. Right, so I've already got my rectangle here. They're telling us that Chandra has 200 yards of fencing. Oh. Now, you know, when we're talking about fencing, think about it. The fencing is, of course, going to go on the outer edges of her garden, right? Which means that 200 yards of fencing, and you got to think about this, is that representing the area, or is that representing the perimeter? Because if you are putting that fencing on the outside edges, then it's going to be, well, it's going to be the perimeter, right? Because it's going to be on the outside edges. You're not covering the whole bottom of your garden floor with the fence post, right? You're going to put it on the outside edges. So that means the perimeter for her garden is going to be 200 yards. So you kind of have to actually start by thinking about what information are they giving us and how I can use that information. So if you don't realize that the fencing is going to be the perimeter, then you're actually not going to be able to go forward in this example. So that's something you're really going to have to think about as you're doing this. So again, she's got 200 yards of fencing, which is going to become the perimeter for her garden. So if this is a rectangular, then you want to think about, okay, what's the perimeter formula for a rectangle? So again, take a minute, think about it. What is the perimeter of a rectangle? So perimeter would be where you're adding all 4 sides, right? Which means we're adding the 2 lengths and we're adding the 2 widths. So you can think of this as being our length and this as being our width. And we know we've got a total of 200 yards of fencing. So that's going to be twice the length plus twice the width. So now we can actually get a head start by using this formula here. So we know we have 200 yards of fencing, that's our perimeter. And then the formula for our perimeter is twice the length plus twice the width. So you can see both of these have 2 in common. I can take that 2 outside as my greatest common factor. And we've got a total of 200 yards. So divide that by 2. This cancels out, 2 goes into 200, 100 times, so you get 100 equals length plus width. So basically we are saying that when we add up the length and the width of our garden, it should add up to 100 yards. Now we actually need to come up with the formula for the area, because of course we are trying to maximize the area of this garden for Chandra. So what I'm actually going to do is I am going to go ahead and subtract W, because I want to have my equation only in one variable. I don't want both length and width. So I'm going to actually go ahead and rewrite my length in terms of the width of my garden. Okay, so we're just going to have L equals 100 minus W. Alrighty. So like I said, we are talking about maximizing the area for this garden. So when you talk about the area of a rectangle, what is the formula for the area of a rectangle? Okay, think about it. So it's going to be length times width, right? Length times width. So we need to use this idea to help us come up with the area of our rectangular garden here. So if we're talking about length times width, and if this is the definition I'm using for length, which is 100 minus W, so this is my length, I'm multiplying it with my width. So you can basically go ahead and distribute that inside your parentheses, which will end up giving you 100W minus W squared as the area of your rectangular garden. So do you see how we came up with that quadratic formula? Because quadratic formula, this basically means that the highest degree on your variable should be the second degree. And you can see my W squared is a second degree term. So this is actually my quadratic formula right here. So you can see how we use that idea of 200 yards of fencing, which was our perimeter, put it into our perimeter formula, twice the length plus twice the width equals 200. We basically cleaned it up where we got length by itself, and we got length equals 100 minus W. And then we go back to the area formula for a rectangle, which is length times width. I make the substitution for length by using this formula 100 minus W, and then distribute that W inside the parentheses, and now you've got 100W minus W squared. So this guy now is our quadratic polynomial right here. So remember, as I was talking about earlier, that when we're talking about maximizing or minimizing, they're basically asking us to find the vertex of our parabola and then using the y coordinate to get our maximum or minimum value. So since this is now my quadratic polynomial, to find the vertex, I am going to use W equals negative B over 2A. So remember, guys, the square term always gives you the A value, which in this case would be -1. The W term always gives you the B value, and we have no C in this case. So when you do negative B, your B is 100. 2 times A, in this case, A is -1. So that's -100 over -2. The two negatives will become positive. 100 divided by 2 is 50. So you are getting your W to be 50. And of course, W is the width, right? So that's going to be yards. Now, if you put this back to find your length, you can use length equals 100 minus W. That's 100 minus 50, which will, of course, also give you 50 yards. So to actually maximize your area, so your dimensions will actually be 50 yards by 50 yards, which means instead of having a rectangular garden, you need to have a square garden to get the maximum area. I guess I want to say a square garden. Oh, this is not working today, is it? You need a square garden to get the maximum area. All right, there we go. So those are what your dimensions are going to be, 50 yards by 50 yards. So it's not really too bad. You start, like I said, by using the perimeter formula and the 200 yards of fencing. Once you get either the length or width by itself, we went with length, put that into the area formula. That's where you actually get your quadratic polynomial from, and then you're just using the vertex formula, negative b over 2a, which actually helps you find that the width will be 50 yards. When I put it back into our little length equation here, at length equals 100 minus w, you get length also being as 50 yards. So that actually tells us, since my length and width are the same measurement, we need a square garden instead of a rectangular garden to get the maximum area. So that's what happens here with Chandra's garden, okay? Alrighty, this is our very last example. I know you guys might be ready for this section to end. So this is our last example here, and you will actually see examples like this in your homework. So this one is talking about if an archer shoots an arrow straight upward with an initial velocity of 192 feet per second from a height of 7 feet, then its height above the ground in feet at time t in seconds is given by this formula. So they're actually giving you the, I guess the path of the arrow as the archer shoots it by this formula, which is, and there should be a little equal to sign here. It looks like I missed that. It should be h of t equals negative 16t squared plus 192t plus 7. So if you will actually notice, this plus 7 here is from the 7 feet where the archer is standing above the ground. The initial velocity of 192 feet per second is actually this 192 multiplied by time t. And then the negative 16, because you know the force of gravity, whatever goes up in the air is going to bring it down. That negative 16 is actually the gravity, which is bringing that arrow back down to the ground. So that's actually how they come up with these formulas. And so they're actually giving you the formula, and all they're asking you to do is find the maximum height that the arrow will reach. So basically think about this, and let me get to our notes here. So they're giving us the formula for that arrow's path, which is negative 16 t squared plus 192t plus 7, right? So they're telling us that that archer, if this is, let's say, ground level, E is standing at a height of 7 feet. And I guess this is my archer. I don't know. Don't expect me to draw. So he's of course going to take that arrow, probably go up a little bit higher, and then arrow is going to come back down, right? So of course you can see it's going to form that shape of a parabola. So when they're asking you to find the maximum height reached by the arrow, they're basically asking you to find the vertex, right? So that's going to be the first part where they're asking you to find the maximum height reached by the arrow. And then they're saying, how long does it take for the arrow to reach the ground? So then they basically want us to know, okay, then at what time will that arrow come back down to the ground level? So that's kind of what this example is asking you to do. So let's start with part A, where they're asking you to find the maximum height. So one thing you should keep in mind when we talk about these ordered pairs here, your time t is actually going to be the x value, and the height of the arrow is actually going to be your y value. So when they're asking you to find the maximum height, they're basically asking you to find the y coordinate of your vertex, okay? So again, to find the vertex, we use negative b over 2a. So looking at our equation, this is your a, b, and c value. So we need negative b. B is 192. 2 times a is negative 16. So that's negative 192 over, that should be negative 32. And then when I divide negative 192 by negative 32, I get 6 seconds. Now they're not asking us for the time, but from the time that the archer shoots the arrow and it reaches its maximum height, it's going to take 6 seconds. But we actually want to know what is the actual height when it reaches that maximum point. So you're going to take this value of 6, put it back into your quadratic equation. So that's going to be negative 16 times 6 squared plus 192 times 6 plus 7. So again, plug that in your calculators and see what kind of answer you're coming up with. Okay, and looks like if my calculations are correct, hopefully I put everything in correctly, is coming out to be a height of 500, well, 583 feet. So it gets pretty high, doesn't it? 583 feet, and it's going to take 6 seconds to get to that maximum height. So this is actually the answer that part A is looking at. What is the maximum height? So remember, you start out with your t equals negative b over 2a, which will tell you the time. Then take that answer you got for the time, put it back into the quadratic formula, and then solve it, and you get the height that the arrow reaches. This was part A. Part B is asking you how long does it take for the arrow to reach the ground. So that is when he's shot the arrow, it's reached its maximum height, and now it's going to come back down to the ground level. So this is actually where, if you think about it, when it reaches ground level, at ground level, what is the height going to be? Well, the height is going to be 0 feet, right? Because it is at ground level, so it's going to be at a height of 0 because it's nowhere above the ground, I guess. So this is actually what we're going to do. You're going to have to take h equal to 0, which means you're taking your quadratic formula and putting it equal to 0. So your quadratic formula is negative 16 t squared plus 192t plus 7. So we're setting our height equal to 0. And you know what? I would use the quadratic formula to solve this. I think that's going to be your easiest bet. So that will be t equals negative b plus or minus square root of b squared minus 4ac, and the whole thing divided by 2a. So that's going to be negative of 192 plus or minus 192 squared minus 4 times a, which is negative 16, c, which is 7, and then the whole thing divided by 2 times a, which again your a is negative 16. Now guys, be careful. One of the things that I have seen commonly happen here is the signs getting messed up. And if you miss your signs, your final answer comes out to be all wonky. So just be careful. So we've got negative 192 plus or minus. Then inside the radical, we did 192 squared, which actually comes out to be 36,864. And then actually, I think this is going to be plus, because we are multiplying negative 4 with negative 16 and multiplying by positive 7. So all of that comes out to be 448, and then divided by negative 32 on the denominator. So let's go ahead and clean up that radical part. So you've got 36,864 that you are adding 448 to. Okay, just a second. Okay, so inside the radical, when you add those two numbers together, you end up with 37,312. And again, the whole thing over negative 32. Now, the thing is, we want to see if this 37,312 is a perfect square, and I have a feeling it's not. Nope, it's not. Let's see. So it's actually coming out to be, I'm actually going to write the whole number down because you do not want to round your answer at this point. So it's actually coming out to be 193.1631435. Yeah, not a happy number. So what you're actually going to do is keep this answer, and then you're going to try and calculate this with both the plus or minus, the negative 192 plus the 193.16. You know what? Instead of writing it as a decimal, I'm just going to write the radical because that's too many numbers to write. Over negative 32, or the negative 192 minus square root of 37,312 over negative 32. So don't round your answers, okay? Keep this number as it is, or just leave it as a radical. And then when you're doing the calculations for your final answer, you can round it. So I'm actually going to type this in as negative 192 plus the square root of 37,312. 37,312, there we go. And then the entire thing divided by negative 32. So this first one is coming out to be negative 0.03634, and it keeps going. Or let's try it with negative 192 minus square root of 37,312, and that is divided by negative 32, which is coming out to be 12.03634, and again it keeps going. So how about we round it to 2 decimal places? So think about this. If the archer shoots the arrow, it reaches its maximum height after 6 seconds, and then it's going to hit the ground, that definitely cannot be at negative 0.03 seconds, right? So that means this is the answer we are not looking for, and you're going to discard that answer, which means it's going to take us obviously more than 6 seconds. So this is going to be the answer that we are looking for. So you can say the time is approximately 12.03 seconds, or if they want a whole number answer, then you would say 12 seconds to reach back to the ground. So this is actually what you're going to have to do for part B. So again, you can see we start by setting our quadratic equal to 0 because at ground level, your height is at 0 feet. We put this into our quadratic formula, and just going through the formula, we come up with 2 answers. One of them came out to be a negative value, so we know you're not going backwards in time, so it cannot be the negative 0.03 seconds. So it's gotta be 12, and I just realized I missed my rounding. That should be 12.04, or as a whole number, 12 seconds is how long it takes for the arrow to reach back to the ground, okay? So I kind of hope this example helps you out a little. And this was the last example that we needed to do in section 3.1. If you have any questions, please let me know, and I'll definitely be here to help you answer those. All right, folks, take care.